Hello, physical geology students. This is the slide that we left on. We were talking about jetties and groins and how they reduce erosion rates along the shoreline. This slide shows basically a breakwater structure that's located here off the coast. And right behind the breakwater, we usually have a harbor. And this is the area where this is the area where it's protected, but what happens is the water migrates around the breakwater and we deposit this symmetrical mound of sand. So what's going on in this photograph here? Is this a jetty or is this a groin? What type of structure is it? First, identify that. And obviously, we have longshore drift that's occurring along the shore. And if we place a groin type structure in front of it, we're going to get deposition here, and on the other side we're going to get erosion and so forth. So it looks like there's some boats that are, I don't know, structures that are docked here close to this structure here. But here you can see, you notice the beach is deposition. You're increasing deposition, so you're increasing your beach here. And a lot of times the whole reasoning is they're trying to mitigate beach erosion, so they'll put these structures in. Also, I showed you prior a couple of slides back about how they can transport sand in and actually dump sand and create, that's the beach nourishment project. But that costs that is a lot of money to truck in sand. So what they do is they try to put these groins in along the shoreline to reduce coastal erosion. So here's kind of a cartoon or a diagram showing depositional features, and that form. This is called the spit. This is a recurved spit here, and this is a bay mount bar. And these are features that form right along the coastline. And we'll look at some features now. This is a satellite image showing the red is all the vegetation. And what do you see here? Well, I see a spit right here, and I see a recurved spit here. Do you guys see a bay mount bar? This is probably the recurved spit. I don't see any here, but here's one. This would be a bay mount bar where it's connecting adjoining land formations. You have one here and one here, so this is kind of the bay mount bar. So you can kind of go back and look right here. So that's the bay mount bar right here. So here's another example of a bay mount bar. This is I think along California. But here it's joining. Basically, it's deposition of a sand-like feature that's connecting to. Here's one as well. So, what is this kind of? It's called a tombolo, and it's basically a deposition of sediment that joins two former mainlands. So you have this is a former island, and then you have another. Kind of the mainland here, and it's essentially what happens is you get most of your erosion here deflected off of here, and the water currents flow into here and deposit a sand that joins these two features, and you can kind of see it right here in this photograph here, and they're called a tombolo. Here's a perfect example. You've kind of got an isolated island, and the waves are kind of flowing around here and depositing. You can see this neck-like feature develop here, connecting the mainland to this island here. And we actually have one of these wonderful features here near the Apostle Islands in the Door County area. And this is the tombolo of Wisconsin. And you can kind of see here's an isolated island, and here we've got this deposition of sand adjoining this former island here. My wife and I have been we saw the Apostle Islands from a distance. We were going to get on the ferry and go out there, but I guess we didn't have the chance that day, but it's beautiful, I heard. And I'd like to do so in the future to visit there. So here's the Gulf of Mexico, Corpus Christi, Texas, in Padre Island. This is the famous island that everybody wants to go to, drink whiskey and beer and enjoy yourself during spring break. But this is kind of essentially the Baymouth. You could say you're on a Baymouth bar along Texas. So this is the depositional feature that forms here. And here's kind of an airplane, kind of an oblique view from an airplane showing Padre Island. And this is a beautiful Baymouth bar. So all your resorts are all along here. And here they don't have too many. This is the beachfront, but I don't see any groins or jetties along here trying to reduce. I wonder how they probably truck in sand to keep the beach there. Which direction is the longshore drift here and why? What can you see here that would give evidence of deposition of sediment? Do you guys see a break? You see a breakwater, which structure is right here. So the breakwater is coming, and you're probably getting deposition of sediment over here. But also, this would be considered a groin, or no, this would be considered a jetty because a river continues to flow in this direction. So longshore drift should be in this direction here, and they put this structure here to minimize. So you're getting deposition here, but you're getting more erosion over. You're getting essentially erosion and deposition over. You're getting this because the water is depositing. So you're getting a lot of unusual types of depositional and erosional features due to longshore drift. So this is down, and if you've been on Lakeshore Drive in Chicago, Illinois, I've been there. We actually visited the beach there, and it was actually pretty cold. There were people swimming, but here you've got these groin type structures, and you can see you have to identify which direction is the longshore drift here. Is it this direction, or is it this direction here? But if you look here, it looks like here you're getting erosion, and it looks like this is deposition. You could kind of see this other layer of sand, deposition, a little deposition. So they're trying to keep the shore, they're trying to minimize erosion here and get more, deposition of sediment along here. I'm assuming it depends on the wind direction, and on a particular day. When I'm assuming if the wind is coming from if the wind is emanating from the southeast, your waves are going to come in here and then hit here, but your waves might come in from. So it's dependent on the direction of the wind that day that creates the surface waves that then hit the shoreline. But here they're having a problem with erosion. So what do you see here? You see, what do you guys? This is beach fill salience behind the island. So here, remember when we were showing you get these symmetrical mounds of sand. So the waves are coming in and then moving around this structure and depositing here. Here's some interesting, this is along Lake Michigan here, but we have some of these, looks like these breakwaters here, and then we're developing these symmetrical type depositional features along the shore. So finally, you should check out this website, but this is geomorphologists and geotechnical engineers especially they like to go into the lab and model all this stuff. And this is basically a physical modeling of a Tumbulo Formation, the research program at the U.S. Army Corps of Engineers. And they can, put these type of structures, these breakwaters, and actually, have this large wave pool and watch these features actually form. And they can kind of, use this as a model for, the natural world. And it's a great thing to do. It saves a lot of money in terms of costs if they can develop it in the lab, and and then implement it in the field. That's the best approach. So check out this website. It's pretty interesting. So that's it for coastal processes. On Friday, I'll get into earthquakes, and we'll look at different types of seismic waves that propagate through the earth, causing earthquakes to form. Or we'll look at the Richter scale, and we'll get into a little bit about deformation of the Earth's crust and so forth. So I'm excited about that, and I'll talk to you guys Friday. Ciao.